Good morning, everyone. Lauren at Graphiant, presenting to you a very exciting webinar today. Today, we're going to be talking about streamlining success with the advanced backbone monitoring and PoP Bringup with Graphiant. Today, Rania and Prince will be presenting, and they are our site reliability engineers here at Graphiant. Without further ado, I'm going to give the virtual mic over to them. Thank you guys again.
Thank you, Lauren. Hi, everyone, and welcome. I'm Rania, and joining me today is my colleague Prince. We're excited to share some groundbreaking advancements we've made in our monitoring dashboard and how we've revolutionized PoP Bringup through automation. Hi, Prince.
Hi Rania. Hi everyone. It's great to be here. We have got some exciting information to share with you today.
All right, let's dive right in. Prince, why don't you kick us off with an overview of the PoP Bringup process?
Absolutely. Traditionally, bringing up points of presence was a time consuming process. But with our new automation tools, we have drastically reduced the overall time required. Automation streamlines the setup, configuration, and monitoring processes, making it more efficient and reliable.
That's a significant improvement. How does it benefit our users?
It means faster deployment times, fewer manual errors, and more consistent performance. We can bring up new POPs quickly and ensure they meet all operational standards from the get-go for customers.
Speed and reliability, two things our customers need. All right, Prince. Moving ahead, let's discuss the process we followed to construct the pathway when bringing up a new POP.
Absolutely, Rania. Bringing up a new point of presence involves three critical steps: feasibility, provisioning, and monitoring. Feasibility. This involves customer presence, multi-tenant footprint, technical requirements, and capacity planning. We ensure that the physical and logical infrastructure can support the new POP. Provisioning. Here we deploy all the necessary hardware and software components. This includes configuring network devices, setting up hardware devices, and integrating to the global backbone network. Monitoring. Finally, we implement continuous monitoring to maintain optimal performance. This includes setting up real-time alerting, notification, and dashboard to keep an eye on the health of the POP and quickly address any issue that arises.
Right. And each of these steps is crucial for a smooth and efficient POP bring-up process. Prince, can you share more? What about our process makes us stand out?
Sure, Anya. What really sets us apart are the advancements we have made recently. Let's dive into those next.
Previously, we did not have much end-to-end automation, which resulted in a partially disjointed process. With these efforts, we were able to streamline our POP bring-up process and time. One of the key enhancements we've introduced is the one-click process to activate POPs in minutes. It's incredibly efficient.
And we have also implemented a single source of truth, GCS, for provisioning and controlling. The central repository holds all the configuration data, ensuring consistency across the network. Extensive validations. We run comprehensive checks to ensure end-to-end consistency. This includes verifying configurations against the best practices, compliance standards, and detecting any anomalies before they become issues. Enhanced documentation. Our unified documentation system provides detailed topology maps, which are crucial for troubleshooting and future expansions. Configuration process. Our structured approach, which starts from configuration, then resolving any issues faced in the process, then verifying all the configurations, and finally making it live, minimizes risks and ensures smooth transitions.
Absolutely. With the new process, it's as simple as following these steps to ensure everything is in place and functioning correctly before going live.
One of the most exciting outcomes of these advancements in the dramatic reduction in POP bring up time. What used to take days can now be accomplished in minutes.
It's a game changer, Prince. Automation has not only sped up the process, but also improved accuracy and consistency across the board.
Now let's shift gears and talk about our new monitoring dashboard.
Absolutely, Prince. Our new monitoring dashboard is designed to give you real-time visibility into your network's performance. It's a game changer for anyone managing vast amounts of data. This tool ensures that you can monitor and control your data effectively, keeping everything running smoothly and efficiently.
That sounds fantastic, Rania. So what's the main goal of this new dashboard?
The main goal is to maintain a stable and SLA compliant global backbone network. We wanted to create a solution that helps on-call engineers triage and solve issues quickly and efficiently.
That's crucial. Now let's talk about the problem we are addressing. Managing data and ensuring timely issue remediation can be incredibly challenging. How do we tackle this with our new dashboard?
That's a great question, Prince. Our dashboard provides a high-level, real-time view of Graphian's global reaching backbone. It offers granular insights into data plane, control plane, and system plane connectivity. This means that the on-call engineers can see exactly what's happening at any point in time and take swift action if needed. Let's dive in. Our global summary view shows a high-level visualization of the health of your backbone. You can also dial in based on either the data plane, control plane, and/or management plane, as well as specify subcategories to filter your view with. This gives you the freedom to view device health at a glance. Scrolling down, we have a matrix summary view of our backbone SLA health on a regional basis. Since each region will have at least 2 of our edge terminator devices, we've created a summary table view that condenses all the important information. Once again, each tile is color-coded, based on health status for ease of viewing and to reduce visualization fatigue. If you hover over a tile, a tooltip with the worst values of loss, latency, and jitter in this region-to-region pair will appear. And if you click on a tile, a list of all the links in this region-to-region pair will appear jitter values. We also have more detailed matrices for each of these metrics, so quality of experience, loss, latency, and jitter, which show us the values on a device level rather than by region for more granularity. With these real-time statistics, we have the option to drill down into specific device-to-device connection level details. Scrolling down more, we have an ET-WAN matrix, which gives us an overview of the health of our WAN circuits per device, as well as the service provider to reach out to if need be. Another key player in our monitoring toolkit is our intelligent alarm system, which gives us insight into any incidents within our backbone. Similar alarms will be aggregated into a list to reduce alarm fatigue. Filtering to find a specific alarm is easy with our search tool. And each entry gives details such as the offending device, when the alarm is first and last seen, as well as any remediation techniques. We also have workflow integrations to notify on-call engineers of these alarms. Notifications can be integrated through Ops Genie, as well as Teams, and by email. Now let's see it in action. So we've prepared a short demo in which we've simulated a network outage in our backbone by introducing high loss and jitter. So immediately we see here that we get alerts through our Ops Genie integration and our Teams integration. As well as email. Clicking on the URL in the description takes us to the alarms page, where we can find specific details on the alarm type and offending devices. Here we see we are getting alarms for high loss and jitter within the backbone. The on-call engineer can leverage the information here to pinpoint when this outage started, how many devices it's affected, and how to recover. Now that we have a root cause, we can acknowledge any alarms with a note for future reference. This helps with information transparency as well as auditing. With the summary matrix, we can view the network health in a tabular format. Here we see that the quality of experience score has gone down, and we also see reported values of high loss and jitter in real time. The on-call engineer can now move on with recovering the global network.
Absolutely. Thank you, Rania. Let's take a moment to highlight some key takeaways from these improvements. Fixed state configurations. Our automated validation process identify and correct outdated configurations. OSPF state adjustments. Automation helps in dynamic adjusting OSPF states to maintain optimal routing. Streamlined operations. Unified tools and processes have reduced the complexity of PoP Bringup. In-house custom tooling. Our custom tools are tailored to our specific needs, ensuring better performance and flexibility. Complex rules. We have implemented advanced rule sets that can run across services, providing deeper insights and more effective management.
These advancements have significantly enhanced our overall efficiency and reliability, ensuring that we can maintain our high standards of service for our customers. Now let's dive into a couple of case studies to see these improvements in action. So our first case study is of a device losing connection to our controller. We received an alert that the WAN circuit was flapping for this core device, and we observed on our monitoring dashboard that the flap was happening continuously. As suggested by the alert, we checked on our service provider website and noticed that they were reporting the same flaps. As an action item, filed a support ticket with our service provider, and they responded back saying that there was a network event in the data center that caused our network card to flap. All of this would not have been possible to triage without our monitoring dashboard, and the total time it took to do this was 3 minutes.
There's a second case study. We noticed that 3 devices stopped sending metrics to the dashboard. No other services showed this. All the monitoring reviews showed the core up and in synchronization. Triaging revealed that devices could not connect to our backend services. Only our alert engine was able to catch the issue with the cores. This resulted in minimizing any network outage. The whole process took around 3 minutes from alerting to finally resolving the issue.
As we conclude, let's talk about our plans for the future. We're committed to increasing the speed of PoP Bringup with more extensive automation. So this includes developing more sophisticated scripts and tools to handle even more tasks automatically.
Additionally, we'll be focusing on stabilizing the backbone health dashboard with more test automation. We are looking to automate the triaging process and remedial steps to enable self-healing of the backbone.
With these future advancements, we're confident that we'll continue to lead the way in network monitoring and PoP Bringup processes. Thank you all for joining us today.
Yes, thank you. If you have any questions, feel free to reach out. We are here to help you achieve streamlined success. Have a great day.